Oceanic exploration during AUV. Underwater drones serve great benefits to versatility, such as detailed inspection or monitoring aquatic environments, ranging from the surface to possibly the deep sea area. In addition to exploration, underwater drones lower the difficulty for humans to access each oceanic floor. While drones continue to improve scientific, industry, and research purposes, these mechanic robots, in underwater, will be presented or facing these significant challenges. Facing environmental factors such as debris as corals or coral debris, sedimentation of wave currents, relying sonars as the primary and alternative navigation because radio waves (GPS) are ineffective when interacted with the seawater. In other words, GPS cannot travel that long in meters than sonars. In the beginning of era of technology, underwater drones initially served for research and military purposes. Following the evolutionary line of technology, underwater drones are currently facing complexity that challenges the drone's tax and mean circumstances. Around the 1950s, the U.S. Navy developed the first autonomous underwater vehicles, which is AUVs. The the spur for collecting oceanographic data. As time progressed, the U.S. continued the makings of the underwater drones, including the earlier development of remotely operated vehicles, or ROVs. They established the deep sea search and rescue. The historical discovery and exploration of the Titanic wreck in 1985, which is discovered by the rove Argo, and the current performance of replacing humans on complex challenges, which is environmental monitoring, geological surveys, and military operations. This new innovation will be said to equip the system powered by thermal gradients. With this system, this innovation is likely to improve the development of underwater drones having extended endurance. Underwater drones being powered by thermal gradients makes a reference to one of the areas of physics, which is heat transfer and the Carnot cycle or Rankine cycle, to convert temperature differences from surface water versus cold deep water into by converting these the temperature differences, um, they convert into the mechanical work to generate electricity or to change Beyonce for an autonomous system. Alright, here is my initial design of the Darwin. Darwin is an AUV with the appearance of a sea turtle. The flippers are designed to be automatically powered through the use of thermal gradients to produce electricity, thus increasing speed for Darwin to move around or to swim faster. To remove the traditional limitations of batteries, Darwin will be designed to have the system utilize natural temperature gradients between warm and cold ocean water. With phase change material (PSM), Darwin can absorb the heat from the warm water above surfaces, thus increasing pressure inside the cylinder to pushing the fluids through a small generator for electricity. If Darwin descends into cold water, it will contract the pressure like a vacuum. So like it will suck the pressure if Darwin descends into the deep water. Between expansions and contractions, the density of Darwin will be changed, which is flowing up and down, while the continuous harvesting process of energy powers up the drone. The designs of Darwin. The choosing principle of physics for this innovation is thermodynamics. The relevant formulas of thermodynamics is the first law of thermodynamics, which is the foundational law that states energy cannot be created or destroyed. They must be converted from one form to another. So I don't know if you can see my mouse, but here is the equation for the first law. The delta U is the change in internal energy, Q stands for heat added to the system, and W is the work done in system. The total energy change in the mechanical system of Darwin equals the heat from the warm water surfaces added minus surface added. once the work done, which is beyond state changes or the generator, yes. When done, rise up to the services. Okay, here's a sketch of the what it's supposed to look like in action. When Darwin rises up to the surface containing warm water, the generator will begin the production of electricity to charge up the batteries of the drone. So this is the drawing the heat water in order to generate electricity, which is powering up or charging up the batteries. Innovational claim. With no worries about the battery running low, Darwin continued to rely on natural sources, thermal gradients as power source, and generator electricity. Fully designing for oceanography, Darwin's innovation would extend the time endurance and increase the efficient level of its impacts. An ability to gain oceanic data that range from months to a year of limiting levels of complexity for humans' performance. Darwin AUV will be built with the cheapest and efficient material as possible. In addition, the design will come at no or low cost to building the power source and generator as the main system and the exterior design of the drone. Darwin can establish long and frequent monitoring with less human input and less cost for the designs and systems, in addition to a year-long process of gathering data of the aquatic environment. As for challenges, however, Darwin continues to face the same challenges yet with the inclusion of new issues that may occur for the system powered by thermal gradients. And whoops, here are the credits for the information. Throughout the course, I encountered quite a few that are unknown or new to me in terms of physics concepts. I acknowledge most of them, such as the laws of thermodynamics and Newton's law, for example. For the topic of my project, I had to pick one that is fair and simple. It's not like the only purpose of that topic innovation, but it's the physics concept I know of. Alright, thank you for watching.